Next up, we have Sarah, one of the Objective IC OGs. A round of applause for Sarah.
All right, like Patrick said, I am one of the original OGs of OBTS, and the first time that we had this in Maui, like a month and a half ago, or a year and a half ago, give or take, I introduced a pattern of life utility called Apollo. So this is kind of a re-up on where it's gone and a little bit more of the Mac support side of it for this one. So this one is exploring macOS with Apollo. All my contact information is up there. It's also going to be at the end. So for this presentation, you don't have to be the person to take a picture of every slide. Don't do that. I will release all of this. I hate it, sitting back at those people. Click, click, every single time. Drives me absolutely crazy. So all the contact information is up there. As far as what I do a lot of things. I have at least 2 full-time jobs. So my just recently changed jobs. I'm now with Black Bag forensics company. They do a forensics utility called Blacklight. I'm going to show an example of that a little bit. And I also do SANS instructing. So I'm sure there's at least 1 or 2 students in here. There always is for this particular class because I teach the Mac and iOS forensic and incident response class. So all my contact information is up there. The slides will be uploaded to the Mac Forensics site. Sorry, so this one. So this Mac Forensics right here. So if you didn't see the word forensics in there, a lot of people don't see that. Forensics community, however, we do everything with F and 6 in it. All right, so version 1.0 of OBTS. I introduced this new tool. It's a Python script. It's a relatively dumb script. I make no bones about it. I'm not a developer of sorts. I do a lot of research, but not a whole lot of development, so I'm just kind of a meh programmer at best. Scripter, not even a programmer. I wouldn't even call myself that. So I released this one, and I really kind of released it as a proof of concept utility. Since then, so about a year and a half, it's being used in commercial products. It's being used across law enforcement across the world in security outlets. A lot of folks are using this particular utility. So I really built it out with iOS in mind first. So what I'm doing is I'm taking your iOS devices, not yours specifically, legal authorization and whatnot. I'm taking those devices and I'm extracting a lot of databases. So you're probably familiar with SQLite databases, Mac and iOS. A lot of really useful data is going to be stored in these databases. So one of the problems I was running into was looking at 20 different databases with maybe 20 plus different SQL queries to pull out and extract all the little bits and pieces of what you're doing with these particular devices. So I created Apollo to basically automate that process for me. So I called it Apollo because it's the Apple Pattern of Life Lazy Outputter. Still very proud of that name. And it's not just Apple stuff. I talk about Apple stuff all the time because that's kind of my bread and butter, but this could also be used for Android. It could be used for Windows. It could be used for what other platforms out there. It does not care as long as it's a SQLite database. So if you want to create your own modules, I will certainly do pull requests for those modules. And if it needs to have some Android or Windows stuff built into the script, quick and easy, just let me know. But all I need is a database file name, a SQL query, and a correlation timestamp. So I'm correlating all of this information. I'll give you a good example of that right at the end of the presentation. So as we stand today, there's 165 modules. So there's 20 plus databases with 165 different SQL queries that I'm running. Once I release the Mac stuff, we're going to be looking at probably well over 200 different modules. That's a lot of work. And most of these, pretty much 99.9% of these scripts were created by me to basically support forensic investigations. So as far as what's new since then, upgrade to Python 3. Had to happen eventually, kicking and screaming, I finally did it. I also do a lot of location stuff. So iOS notoriously stores a lot of extremely awesome location data. It is protected, don't freak out, it is protected. But I can extract that, throw it into a KMZ, pop it into Google Earth, and see, where have you been for the last few years, weeks, days, all sorts of good stuff like that, particularly like the location information. I've updated a lot of the iOS modules. I keep adding more and more and more. There's really no lack of data to be pulled out. It's just a matter of building queries. Some of these queries take a minute to create. Some of them take weeks to create and make sure that you're doing the research. One instance, I was going to present on screen time today, but when I was in the plane, I was really looking at what I had. I'm like, this isn't right. You have to do testing. So whatever my query was doing was not extracting the right information. So I'm going to hold those back for a little bit so I can look at that a little bit closer on. And now I did mention also commercial tool support. So this is all open source. You can go in here, grab them today. The macOS stuff will hopefully be released soon. I'm hoping for next week. And that's great. I put them out into the community so the forensics folks can use them. You know, it does take a lot of time to build some of these queries. I am fortunate to do a lot of research, so I want to provide those to the community themselves. So a lot of the commercial tools, some with permission, some with not so much permission. My license is very lenient, for the record, have built them into their tools. So I now work for a Black Bag, and we have a whole basically plugin that they built around Apollo. There's really only one plugin, and it's Apollo. So they really built it around what I had released. And this was before I even worked there. Now I truly work there, and I have to keep it updated, which is excellent. Axiom is also another one. So if you do know these forensic utilities, Magnet Axiom also takes some of the modules. Not nearly as many as Blacklight, but you will see some Apollo stuff being stored in there as well. So just as an example, we have here, this is Blacklight Black Bag. So this is the company that I do work for. Got to give them a little shout out because they built this whole piece just for my Apollo stuff. So plugins, it doesn't worry about my crappy Python script, which is a good thing. It basically takes all the modules, all 165 modules, and throws them into the different tables that you see here. So this means, you know, forensic investigators who are already using Blacklight can already go in there and see all these different tables. They don't have to do anything special. It's built right in. You might want to update it because I update these modules very often. That's it. So it's pre-built in. As soon as I release the Mac ones, again, hopefully next week, boom, automatic support for all of the Mac ones that I'm going to show you today. So I will do demos of this. I am doing the arsenal today. Yeah, so today. So if you want to see a little demo of Blacklight, happy to provide that as well as the script. So as far as new modules, so I am specifically focusing on the Mac OS side here. I already did iOS. I got that pretty well covered, but I'm looking at the Mac side here. So I'm going to go over a few of the different databases that you see up on the screen here, but this is only a fraction of all the modules that I'm going to be releasing next week, maybe 10% or so. There's a lot more. I just don't have the time to talk about each one of them. So the first one I love, Knowledge Seed. This is on Mac, this is on iOS. It's one of my favorite databases. It's weird, right? I have favorite databases. I have favorite plist files. Forensics people are strange people. So Knowledge Seed. This one's really keeping track of user activity. So I focus most of this on iOS. Want to focus a little bit on the Mac side as well. What is the user doing? Can I track what they're doing? You know, pattern of life, it's really just detailing what is happening with the user interaction. What are they doing? What is the system doing on as a whole? And I can get very, very specific information and a lot of different fragments, correlate those together to really tell the story of what happened on a particular device. So first things first, what application is being used from a particular user? So I have a few examples here. I actually want to make this a little bit larger. Give me 1 second. I hope I don't screw things up. Perfect. All right. I couldn't see it on my screen, but you can see it up here. So what you're seeing here is the query output. So this is not the raw database. This is the Apollo module that's being run against the database. That's why it might look, you know, sort of standardized across a few of their screenshots that you might see here. So what I'm seeing here is the bundle ID. So everything on Mac and iOS, application-wise, service-wise, has a bundle ID associated with it. So if I'm looking for a specific service, a specific application, very likely going to be looking across all different databases, plists, what have you, for a particular bundle ID. So this shows me which applications are being used on this Mac at this particular time. Now, a little bit different than iOS. iOS, you might have multiple applications running and you have to flip through them. macOS, you might have multiple applications and they're all storing the same sort of timing information, the start and end times. So knowledge seed across these two platforms, a little bit different. That's why you see this usage in seconds and minutes here, about 5 minutes or so, for all of these applications, because they're all running and they might be on multiple desktops. We're going to look at another query a little bit later on that shows which one is in focus at a specific time, or the frontmost app, if you will. So you can see more specific user activity with that. Now, the items that I have highlighted here, these are all from an iOS device. So specifically with Knowledge C, if you have iCloud set up and all services turned on and whatnot, a lot of this stuff is going to be synced across devices. Forensically speaking, this is bonus. If I only have the user's desktop information, but I can't get into their phone, or I can't access their phone, or don't have legal authority to access their phone, I can still see a lot of that activity that's being synced back to the Mac. That is fantastic. So what you're seeing highlighted here is my activity on my iPhone device, the one I have right here. So I'm on Twitter, because I'm always on Twitter, camera, Waze, all of that good stuff. So I will see the combination of both Mac and iOS devices within the Knowledge C database. Other things within Knowledge C, this is going to be pretty standard across all these other queries. You get the day of the week, GMT offset, which is useful, especially if you're traveling back and forth, and start and end times for that particular app usage. Notice the ones for the Mac side, they're all pretty much the same. On the iOS side, we use one app at a time. That's the major difference. Next one, still Knowledge C. We're looking at a completely different query. This one's going to be application intents. So this one's going to give me a little bit more context. So I know what application the users are using, but what are they doing with that application? So in this case, I really see quite a bit more iOS related stuff than macOS related stuff. And this is pulled on the Mac. What we're looking at today was not pulled off of an iOS device at all. This is all just synced to the Mac itself. So we have the application name, bundle ID. Intent class is going to give you an idea of what you're doing with the application. Mobile SMS, I'm sending a message. Com 8 bits tweety 2, compose message, so I'm sending a direct message to someone, I believe is for that one. Looking at trends, search, you kind of get an idea of what's being stored in there. And same thing with the intent verb. I'm doing send message, something like that. And then I have this other highlighted section, the serialized interaction. We're just talking about NSKey to archive plist files. If you ever want to know more about those, talk to me, because I swim in them all day long. Forensics people come to hate them because they're serialized. There's not a whole lot of context. You have to rebuild that context to that. So if you're looking for examples, call me. I know where they all are, more or less. So we'll take a closer look at that one just a little bit. Next thing we have, and it's very application specific, is this group ID here. It's going to tell you what chat, maybe some contact information in there, and a few other items. Now, same thing, I'm just kind of zooming in and showing you some other examples here. So I got some music intents. If I'm searching or selecting specific artists to listen to, I can open those up and see, which artist I selected. Assistant service, Siri type of stuff, so maybe navigation items here. And I specifically picked this one, Apple Find My, because I was on my phone and I was waiting for a friend of mine. So I have her find my information on my phone. And I was basically stalking her. We were supposed to meet up in New York. I'm like, where the heck is she? And she's basically just trapped in traffic, more or less. So I could see her going to Broadway and stuff like that. So I was constantly digitally stalking her at that particular time. So I can actually see that stalking, if you will. I use the term very lightly. We're good friends. She knows that I have her in my Find My. So I extracted this serialized interaction, this NSKey to archive plist file, and I'm able to see who I was trying to look up. And if I have 10 other friends in here, maybe I'm looking at one versus another. So you get a little bit more context on what the user is doing. Just another mention, these blobs here, I don't do anything with these blobs for Apollo. It is lazy after all, but I do bring them out to hex so you can bring them in, save them as plist files, do whatever you want to do. And I certainly could have done that with this one, but this one's very, very special. This is NSKey to archiver binary plist, but it has multiple NSKey to archiver binary plist embedded into it. So you have multiple levels of a plist inception going on here. So I was lazy, I just threw it into a hex editor so you can see kind of what the contents of that are. It's not pretty to look at. Next one we have here, web browsing. So web browsing, I can extract from a few different places. I have the Safari history database. This one's mostly going to be only Safari specific. It's not going to do anything with Chrome or Firefox or any non-Apple browser service here. So this Knowledge C is also keeping track of browsing information, and not private browsing. That's the unfortunate piece here. That does not get recorded into this database, which is a good thing, I do believe. So we see it bouncing back and forth with the app name or the bundle ID. We have Apple Safari, that's the macOS Safari bundle ID, bouncing to Apple Mobile Safari. So it's me bouncing back and forth between Mac and iOS devices. Also, I have highlighted here multiple device IDs. This is where using this for web browsing forensic analysis is actually a little bit more useful. If I'm looking at the history DB, the one that's under Safari specifically, collecting all your visits and URLs and all that good stuff, it does not tell me which device. It tells me it was this device or another iCloud connected device. So if I'm curious, I need to expand my options. I might go to a Knowledge C database and see which device. So this is the hardware UUID. This 22801, this is my iPhone. This 55201, this is my iPad. So I can see myself browsing across different devices. So I get a little bit of bonus extra information in Knowledge C, which is fantastic. All right, what else? Other than that, we see the browsing, the timestamps, the URLs, all that good stuff. Stuff that I would expect to find in other databases as well. All right, next up, application notifications. So if Samuel was pointing my phone and it's sending all those different messages, if I have the message syncing being turned on, probably going to get those messages on macOS as well. So you'd be able to see a lot of the notifications coming in across the devices as well. So again, we have the bundle ID, a couple little shout outs. I used, of course, DND from Digita. So this one is doing the notifications. So open up my laptop, right? Shout out, right? Open up my laptop, gives me the DND notification on my phone. It's also syncing that to this particular database. So I can see when people are doing whatever with the different devices. And then we have System Center Apple software update notification. Probably very familiar with this one. Please update, please update, please update. And you keep saying, no, not today, not today, not today, right? Yeah, so I can see that you are not installing your updates on a timely basis. Other ones in here, I have things like news and email and messaging and all the other ones for notifications that you would expect to see here. So there's different types. The hardware information, again, it's basically combining them from both platforms and a little bit more information, things like messages. And I can use a lot of these different GUIDs and UUIDs and things like that to target, which email was notified at a specific time. So everything in the Apple ecosystem will be tied together very often with some sort of GUID or kind of tag with that one. A few other app notifications. So same one that I was just talking about, just on a per app basis. We have Little Snitch. So I got Little Snitch installed. I got all the things installed. Little Snitch installed. It wants to open up a new process. I received that notification. Can't tell here what application or what process or any other information, but we'll be able to see that in another database. This is another reason why I created Apollo. If I'm just only looking at one database at a time, I lose the context of what might be happening in other places on the file system. So we're going to see Little Snitch a little bit later on. We got Notification Center Ask Permissions. You might install some application, and of course it's going to ask you, hey, can I get access to whatever, microphone, pictures, what have you. We're going to take a look at the TCC database in a little bit. Sharing D. What's Sharing D associated with? Say that again? AirPlay? AirDrop. You're thinking AirDrop, right? Yeah, AirDrop, in reality, it's all continuity-based services, but specifically for this one is AirDrop. We're going to see that one a little bit. So if I get something AirDrop, little notification pops up. I can see that. And then finally, these are notifications from my iOS device. So I don't have Signal installed on my desktop. At least I don't think so. No, don't have it installed on my desktop right now, but I do have it installed on my phone. So if somebody sends me a Signal message, I get a notification, and then I see it also getting synced into this database. So again, you have that cross-contamination piece. I hate to use that word right now, but you see that being synced across the different devices. Awesome from a forensics perspective. All right, and one more for Knowledge C, now playing. This is what's playing. Honestly, I'm either rocking out to Apple Music, I'm maybe watching some videos, playing some videos, or if you are looking at my device, you're gonna see a lot of Apple WebKit web content for Twitter, specifically. This is me scrolling Twitter on my iOS device over and over and over. Every little GIF, every little video has another entry in there. I have a lot of these entries on my own particular device. And you'll notice the usage in seconds over here. They're 0, 1, 2, 3 seconds. So I'm really honestly just scrolling, kind of just to peruse whatever is on Twitter. Oh, and the new Grimes album, pretty awesome. Totally listen to it. All right, next database. So that was all Knowledge C. Knowledge C has a lot of different items in there. It is, again, one of my favorite databases. So next up, network usage, or netusage.sqlite. This one is more or less keeping track of all the different processes and application and the data that's being transferred across different networks. So you get the timestamps in there, some bundle IDs and process names, and I have highlighted here 3 different sections: Wi-Fi in-out, WWAN in-out, and wired in-out. These 2 are interesting. Wi-Fi, cool. I have a MacBook Air here. Of course, I'm going to connect to the network over Wi-Fi. WWAN. Okay. Not quite sure what I have for this one, but I do find that it's a lot of Mac-specific processes. So I don't know if it's kind of internal processing or maybe Bluetooth or something like that. So I'm going to have to investigate that one a little closer on. And then we have wired. I have never had a wired connection on this laptop before because, I'm a Mac user. Who does that, right? But yet, I still see data being stored in here for that one. So I have a little bit of investigation that I have to do. There's actually quite a few different modules that I have yet to do some investigations of. How can they be useful? Why do they get populated? The whole reason, again, why I created Apollo is so I can make that testing a little bit easier. So I can run these live on my system and say, if I do this, what does it look like in the databases themselves? So for net usage, this one I'm going to look into in particular, try to figure out why is it being stored in one place for, say, a wired versus Wi-Fi. What is the internal processing of why that's being stored in there? Next database, Interaction C. So this is also kind of under the Knowledge C area. It's all under Core Duet. This one is great for contact information. So who's talking to who, all that kind of context. So I've got start information in here, bundle IDs for which application is in use at that time, the display name. So this is who I'm talking with. Obviously, I'm in here and I'm chatting, going back and forth through iChat messages with Heather Mahalik. And every once in a while, I get one for an email in here. This one with Braden, this is my cat sitter. Whenever I travel, and I travel a lot, talk to him, he sends me cute cat pictures. Anybody can send me cat pictures, doesn't even have to be my cat. I would highly appreciate it. Talking through email with another friend of mine, Jessica Hyde. So we see the interactions with that. So it gives a little bit more context to the data that's being presented here. Apologies for the redaction, but I'm pretty sure nobody wants their emails and numbers being presented at these conferences. So I got to do a little bit of redaction here. And then we have this person ID. And again, this is where the Apple ecosystem ties everything together. Whenever you see these AD person records, this means this particular contact is in my contacts database. I knowingly put that in there. So I have one, of course, for Heather Mahalik. Everybody gets a unique ID associated with that. And I can go to the contacts data area to find pictures associated, other metadata, other contact information associated with that contact. Everything is being tied together. And then we have another notifications. So we don't just have one notifications, we have actually a few different ones. This is what's commonly known as the notifications database, Apple Notification Center. File name is file path is DB2, and the actual database is just called DB. Cool. Nothing else in the world could possibly be called DB. Yeah, there's actually 2 databases that I'm going to talk about, both called DB. So this one's keeping track of more notifications. The bundle ID. So this is me being, notification harassed by Slack. You know, all of a sudden some Slack conversation really gets heated and you get bam, 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 Slack, Slack, Slack. Down here, I got my little snitch. So I either ran a program or opened something and was calling out to some place. This is where I can get a little bit more information about what's happening with that little snitch connection, because I have another blob here, and this is another plist. I don't believe this one is an NS keyed archiver plist. I think this is just a good old binary plist. And forensics people will often find 6270, 3030, BP list 00, the header. Once you start seeing that over and over, a lot of the blobs are going to be stored as binary p-lists of some sort in some of these databases. So if I open up one of those, this one's just a nice little p-list, not too big to handle here. Shows me, of course, the app little snitch, bundle ID. So this is Google Earth Pro. So I just opened up, executed Google Earth Pro, and I wanted to make a new silent mode connection. Very much the same text that you're going to see in that little snitch pop-up in your upper right-hand corner. But it gives me that more context. All right, now let's go to current power log. This is the bane of my existence. Current power log PLSQL database has approximately 120 different tables in there. So there's small databases and there are extremely large databases, and PowerLog is probably one of the more extensive databases out there. The other thing with PowerLog is that it likes to store its timestamps with an offset. Don't know why. I honestly have no clue why, and I would love to know, and it's probably the dumbest reason in the world, but this is why you're seeing adjusted timestamp here. So there's another table in this database that has all the offsets by seconds. So in this case, the offset for this one is a lot of seconds. iOS, I've seen anywhere from 20 seconds off, 12 minutes off. If you do this calculation, we're looking at about a month off. And if you're not used to doing forensics on PowerLog database, you just see a timestamp, you're saying, oh, okay, this is obviously February 6th, 2020. That is absolutely incorrect. And from a forensics perspective, you want to be as accurate down to the second as possible in many cases. You know, this stuff is going to court. You don't want to say that this specific event happened a month prior because you're interpreting the timestamp wrong. So this is why I always do testing. I have not seen this issue anywhere else other than specifically the PowerLog database. So I have this extremely weird multi-select SQL query to basically interpret that offset table. Now, it might be 1 or 2 seconds off just because I can only do so much within SQLite. If you did this programmatically, it would absolutely be a little bit more accurate. But we're looking at 1 to 2 seconds. And I let people know that because that 1 to 2 seconds could come into play at some point. So this one, we have the frontmost app. Knowledge C, we saw the applications being used. This one's going to say what's being used right now. What is the user looking at this particular time? Again, by bundle ID, there's the ASN, the Apple's system number in there, as well as an application type, usually system versus third party or whatnot. So it gives me a little bit more specific information. Now, another kicker with PowerLog is really only keeping this information for about 3 days. Knowledge C, we're looking at about a month worth of data retention. PowerLog, 3 days. But there's also PowerLog archives, and I've seen a bunch of those. So you might have, I don't know, give or take 2 weeks if you look at the archive files with the PowerLogs. So data retention is big. You can't just, get an image of the device or just rip a database out of the device and hope that it sticks around. If you don't have it within 3 days, you don't have it. It's not going to hang around for too long. Another current PowerLog, app info. So this is keeping track of more or less applications that were being used, again, the last 3 days or so. It's going to keep track of name, executable names, a lot of different display names in here, the bundle ID, as well as a lot of the versioning information. So if I'm constantly updating things within 3 days, I can see that versioning get updated in there. So this is not every application on the device. I can certainly go to a lot of the info P lists and extract a lot of the same information from these, but it's the last 3. So I get some user interaction for the last 3 days worth of data. A couple other ones as far as users are involved with current PowerLog. Clamshell state. We all have laptops pretty much in here. Open, close. Sometimes as a forensic person, I want to say, is the user actually using this? And I can look at a lot of data, a lot of activity in these databases. I want to see, is the laptop open? Is the person actually, assuming that they're standing there, actually see stuff and is actually interacting with the system itself? First things first, is the laptop closed or is it open? So pretty simple. This one's one of the easier ones in the current PowerLog database. 1 is closed, 0 is open, and you get all that great information. And then this one is kind of specific to Mac itself, idleness. So a user may be there, or they might, go walk away from their systems for a while. I'm pretty sure it's configurable, but mine is set to timeout for about 5 minutes, and that's when these timestamps tend to, change back and forth. So user is active, and a timer starts. As soon as they're not active, timer starts for about 5 minutes. If it hits that 5 minutes, an entry is written into this database. They come back, another entry is written into this database. So just being able to put a person or hands on keyboard can be quite useful in many investigations. All right, so let's talk a little bit more about the security aspect. So I could do user activity all day long, but I also specifically on the Mac side want to look at the security aspects of the system. Maybe I'm doing a examination post-compromise. I want to see what happened with that. So nice little database, tcc.db. Transparency, consent, control. You install an application, it's asking you which permissions you want to allow it. This is what's keeping track of those selections. Get the bundle ID, the service here is going to tell you what type of permissions it is. Camera's camera, microphone's microphone. Nobody seems to know what Liverpool does, and I'm I have an idea of what it might be for, but would love to have that discussion later on, especially if somebody actually really knows, not guessing, but like actually knows, because you cannot find any documentation on that other than a few articles that I think Howard Oakley has written about. So we'll talk about that one a little bit later on. Bundle ID for the client and whether it's been allowed or not. So whether the user says, yes, it can use the camera or not use the camera. And on the newer devices, 1015, we do have a last modified. So TCC did not always used to have this last modified timestamp. This is the other thing with databases. The schema changes all the time. So one version from another is not necessarily going to be even close to being the same. So last modified, if I changed this permission recently, or if some malicious user changed this permission recently, I can put this into my timeline and say, okay, it's doing something, with this particular camera or microphone permission. So there are 2 of these TCC, one for user, which is more, of course, user specific, and one for system level stuff. And this is where you're going to find these policy all files or give full file system access to whatever application. So make sure that you're not just looking at the one database, but all the databases. They're called tcc.db across all the platforms as well. So it's nice, got one table that's useful, nice little database. Really appreciate it when these databases are simple. And then we have this one, launch services quarantine. I think we all are probably pretty familiar with quarantining here. If I airdrop something, if I download something and that application or service supports quarantining, it gets an extended attribute, there's some spotlight metadata, I launch it, it's going to be checked against the XProtect signatures, all that good stuff. So there are databases keeping track of some of this quarantining information. Certainly going to be useful in a post-compromise. So we got timestamps. We got the bundle IDs associated with the application quarantining. Again, what's sharing be? In this case, airdrop. So I airdrop something myself, so we do get to see a little bit of external information. I did it, if somebody else does it, their information will probably be in here as well. If I download something through an application, in this case, I have a Chrome one, it's going to give me some URLs associated with that, where the original data came from and the referring URL. And all these iChat ones, this is simply people sending pictures to me. So every picture that comes in through messages does get quarantined and saves all of that information. This event ID here, this is the one piece that I can use to find what file, what image, what executable was sent to me or got onto this device, assuming that the quarantine extended attribute still has that information in there. Sometimes it disappears and you just don't get access to that. So we can pair that up with specific file system-based information and metadata. and a few other databases. So two more, and this is in the system policy configuration, kind of deep down into the file system here. It's called exec policy. This one I'm still certainly investigating, but I see a lot of signing information. I see applications being used in here, and the timestamps usually map up with the usage of these applications, whether this bundle is signed or not, whether it's actually a bundle ID or not, versioning, team identifiers, signing identifiers, CD hash information. This is only the first part of the query. There's a lot of stuff being stored in here. Second piece, executable hashes, so this is SHA-256 of the executable itself, timestamps from the executable, file sizes, library is used, responsible identifiers, basically what kind of prompted to install this or use this, is valid and is quarantined. So a lot of different executable information being stored in here. So if you're looking for something in particular, this could very much be a good one to look at. So this is exec policy. And it's called Executive Measurements version 2, as the table name is called. Next one is exec policy scan. Same database, different table. This one we're going to see some volume information. What volume was this file or executable or bundle being stored on? Most of mine are APFS. We can see right here with the object ID is likely the inode number for this particular executable. And then we have a little random HFS one here. Folks are still using HFS, just not completely gone just yet. So again, bundle IDs, hashes, identifiers, all that good stuff. But I do want to take a look at this malware result one. Does one mean yes? I don't know. Pretty sure it's not, because otherwise I have a lot of malware on my system. Kind of one of those things, like I'm sure it's, was it checked against Xprotect or something like that? I don't know that for sure. I'm still investigating that, but would love to hear people's opinions. So still testing quite a lot of these. Then we have exec policy scan targets, very similar to kind of what we saw before. We get the path of the executable and the responsible path. I think this one's particularly interesting because if I'm in terminal, Apple terminal, and I'm running certain things, so of course I'm running checkra1n. Shout out to the jailbreakers and exploit developers. Thank you. I cannot do my job without you doing your job. So I really, really, really appreciate it. Thank you. I owe you all a beer. Just honestly, I can't thank you enough. I would hug you, but that would be weird and also contaminating. Also, I don't really hug, and that's not what I do. Yeah. So we got checkra1n here. Executed checkra1n from my for terminal application. Another one I have here, got OpenSSL because I installed iProxy, libmobile device. I use that a lot for research. A few other ones, if I'm download something, goes to my default downloads directory, I execute it. It's going to be located in here as well. So you could see that. Or the user is downloading things they shouldn't be downloading and executing them and just being like gatekeeper, whatever, I don't care, keep going, going, going. Nobody's ever done that, right? Yeah. Well, we can see that all in these databases. So I'll see the user infecting themselves because that's what people do. All right, one more, text policy. So the same directory, other one was exec policy. This one's text policy. Maybe this is the last year for this one. Don't know. This one's called text load history. It shows some of the kernel extensions that I have loaded. Not every single one of them, but some of them are in here. Quick shout out to Lulu. Thank you very much. Always got all the things running in here. And then we have one for OSX Fuse. So just to kind of give you an example of some of the ones in here. So if you're thinking you have a malicious kernel extension, hey, maybe take a look at this particular table. All right. So I know I only have a couple minutes. Oh, I'm over time. Oh, it's fine. 2 minutes. So why Apollo? I have all these different databases. I want to put them all together. So the whole point of it is correlating this across different devices. So I have this little contrived example here. I'm doing quality assurance research into syncs. Not really. I need a video for a presentation. I am in the bathroom. I'm doing QA on this thing. Got a great one. I send it over to my Mac via AirDrop, and then I open it, execute it, open it up, watch it before putting it into my super exciting sync QA presentation. This is a real bathroom that I went to down in Brisbane, Australia. If you notice that when I turn that, all the syncs turn on. Oh, look, I could turn it on and off. Mysterious ghost syncs. Yeah, all right, so that's a 20-second video. Love it. So what do I see when I actually correlate all the Apollo stuff? So I'm making it real quick. All right, application usage, frontmost app, I'm using Sublime here. So different databases will record the same information. So one's coming from Knowledge C, one of these is coming from PowerLog. So doing my sync QA, I'm using Sublime. It's because I'm writing Apollo modules right now. So notification, I want to send that video to myself. When I do AirDrop, it gives me a notification. Sarah wants to send you this sync video. Cool. It downloads. It gets quarantined because AirDrop and Sharing D supports the quarantining functionality. So I can see that in here as well as Sharing D, and it's from me. More notifications, switch to the applications. I want to play it. Apple QuickTime Player. More app usage. There's a lot of app usage in here. We got video ones. I didn't go over these specifically, but there's a lot of ones that show different video aspects of what's being played. This one's showing me that I'm playing one here. A few more down here. This one's showing specifically I'm playing it with QuickTime Player X. State of 0, state of 1, more or less just pressing the play button. And then now playing here, these are coming from the Knowledge C. Notice that the timestamps are the same. These two entries really actually need to be flipped because I was watching this one. Where is it? Yeah, duration here is 19 seconds. And this is my QuickTime, so this is my sync video. And while I was doing this, I was listening to music before, Apple Music, music application, and it switched back and forth. So it stopped playing Apple Music, went to QuickTime, and then went back. And I was listening to Halsey at that time, some good pop. And that's that. So this is about, what, 1.5 to 2 minutes worth of activity. You can imagine combining all this on a whole system for, you know, maybe 4 months, 4 weeks, plus some other information. Every database is different. You're going to get thousands and thousands of entries. I believe on my Mac system, when I ran Apollo last, it was probably about, I think it was 200 or 300,000 different events, which is very small compared to iOS devices, which can be in the millions. So you really want to target what you're looking for. Maybe you're only looking for a specific process ID. You've got some weird things going on there. This can also help out because you'll find that in a lot of places being recorded in these different databases. All right, that's it for me. As usual, I always go long. So if you want to play around with GitHub, it's up there. The Mac stuff is going to be hopefully released very soon. I also have to regress it back to a couple of Mac versions. So I have 10.15 support now. I might go back to at least 10.13. If you want to write some Android or Windows modules, please do. I am not going to do that. I am not that person. But Apollo will support all of that as long as it's in a SQLite file. It doesn't really matter. I have a few more support things like the gzip PowerLog archives I have to deal with. I want to make more modules, improve some output. Other than that, that's all my contact information. And I will be doing a demo this afternoon. So if you have a particular scenario, I love doing that. So if I can do it, run it and show it to you, that's the best way that I can at least demo this particular tool. So think about it over lunch and get back with me. So thank you very much.